tried my email account, Yahoo,
Yeah.
my student number.
I don't have any administrative authority on that server, so I can't really help you with resetting your password. They don't trust me.
Legally, at least.
What?
You can't help them legally, at least.
No,
Google just uses the D2L database for passwords and usernames, right?
I don't have access to D2L. Well, with
Well,
D2L,
I'm
it's
saying Moodle uses the database for D2L.
correct. It uses the Active Directory, which is the same as a D2L. All right, let's go ahead and get started. I have to reconfigure my panels. Okay, so this is actually a good introduction to an operating system because we are looking at a lot of settings related to an operating system. This little part here in Linux, or in Debian Linux, or at least with this Windows. Questions? Okay. This is called a Windows Manager, and this part here is called a panel in XFCE4. That's the name of the interface. And you can do the same thing with the Windows taskbar, which is the same concept. You can make it automatically show and hide, which means when I'm not using it, it will hide itself, so I have more screen space, and I can do the same thing to the top bar. Can Windows do this? Have a split panel? Okay. So it's
split
the same.
panel?
Sorry?
A split panel?
Not a split
Two
panel per
taskbars,
se, but
basically?
basically two taskbars.
Yeah, if you reprogram the user interface, which is really easy.
Yeah, if you download an extra program, pretty much.
Oh, okay. So you can.
You can only have one taskbar per screen.
Oh, okay.
And then the thing is like when you have multiple screens, it's one joined taskbar.
I'm suspecting a lot of stuff is actually hard coded in Windows, and that's why it doesn't have the flexibility.
Yeah, you have to download a couple of programs that you have to pay for in order to get multiple taskbars.
Oh, really?
Yeah.
Not here. Not in Linux. It's all free. But that's also another topic is, what exactly is an operating system? Okay, we are moving on to chapter 4, very slowly, we're moving on to chapter 4. The question is, what exactly is an operating system? We talked about it a little bit last time. So we'll go ahead and open up the textbook and point it to the right place. This is a kind of interesting and useful topic. Apply your knowledge. Use Windows, Mac, OS, DOS, and Linux. We're not going to do that. You can play with it if you want to. Using virtual machines is actually really easy to play with Linux. But with Mac OS and Windows, those are proprietary operating systems, so you cannot just download a virtual machine with it installed already and play with it. I wish it were that simple, but it's not.
Oh, it is.
But I cannot say that. You can say it.
I'll say it.
Okay, so we'll go ahead and get started right away. I'm going to skip a few topics here. The try it part I'm going to skip. And instead we'll start with this part. What exactly is an operating system? Now, with this one, it shows all these screenshots, which seems to suggest that this is what we expect from an operating system. That may be a shifting standard, because back in the good old days, when we talk about an operating system, that's not what we are expecting. In Linux, even when we're using Linux, what you're seeing here is not really a part of the operating system. What you're seeing here is called the GUI, or the Graphical User Interface, which is an add-on on top of an operating system. Okay. What I consider the operating system, or the minimal operating system right now. But I can also, using the graphical user interface. I mean, you guys have seen this. I have used a graphical user interface. Excuse me. I have used a command line interface inside the graphical user interface a lot of times, and that's because I can do this a lot faster than using the point and click method to move files, to delete files, to check out what is in the folder, to make a new folder, and stuff like that. Why do we have to learn command line interface if you are going to work with computers a lot? Why is it something that you eventually will have to learn how to use? Go ahead.
Because you can do more. Because there's certain features that you can't do just with the GUI.
That's correct. Okay, a lot of times, the core features of the operating system is all command line interface. The graphical user interface will simplify things. It gives you an easy way to do things, but it doesn't give you all the flexibility.
Could it be also that there's like something wrong with
The graphical
user interface?
Mhm. Then you can use the command line interface to rescue or fix the system, so you won't be stranded, completely. That's a good point. What about using the computer remotely? Okay, if you are to manage multiple computers, you have your home computer, you have your office computer, and for the most part you use your laptop computer, and you attach it to your cell phone, because you have a 4G or 3G plan, so that you can use that as a terminal to everything else. What do you do when you need to download a file from your home computer? You can use a graphical user interface, but what if you want to do certain things on your home computer and say, okay, I better start a system backup now? How do you run programs remotely so that you have your laptop computer or even your cell phone and be able to run commands remotely on your home computer?
Command
Sorry?
Command prompt?
Command Pro?
Prompt.
Prompt. Okay, command prompt. That's one way, because you can log into a computer remotely. Now, when you log into a computer remotely, there are ways to give you the entire GUI interface. In other words, if you have a 1080p monitor at home, it is possible to kind of display that locally on another computer. But the question is, well, this is actually a good reminder for me to turn off my ringer. Okay. Do you think I can run my PC screen remotely on this cell phone and still be able to use the graphical user interface effectively?
I mean,
Yeah,
probably.
Probably not effectively, right? I mean, I can probably use it. I can zoom it in and pan a lot to look at the entire desktop, but it won't be very useful. I have a program called, I cannot remember the name, ConnectBot, 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 installed on this computer, and I have OpenSSH server installed on my home computer. So I can actually run commands remotely, command line interface, commands, I can run it remotely. So I can do things with my home computer. I can transfer files, I can delete files, move files, I can even edit my class notes and stuff like that remotely using my phone. It's not the best interface, but yet it is still doable. Okay. What is one other reason why you may not want to run your entire GUI remotely on let's say something that's connected by wireless connection?
Somebody else can get into that connection. Possibly.
If they can get into it, they can get into this as well. So that's one consideration, but not the only, not the most important one. How about bandwidth? In other words, how much networking speed do you need to run a GUI like this remotely versus a command line interface? The command line interface is just this, right? You type ls, you press the enter key, it shows the files that are in the current folder. When you do it using the GUI, look at all the things that are being done here. Okay. When you refresh a page like this, when you scroll, it has to repaint a lot of stuff. In other words, if you try to run this interface remotely, it'll be exceedingly slow. Okay, depending on your cell phone, your plan, you can run out of your of bandwidth pretty quickly, because this takes a lot more transmission, a lot more data in order to render a screen like this, as opposed to something like this one. It doesn't take up a lot of bandwidth at all. Any other questions? But even this is technically not really the operating system. This is what we call a shell. Okay, S-H-E-L-L, a shell, as in seashell. This particular one is called Bash, B-A-S-H. It's called Born Again shell. And born in this case is B-O-U-R-N-E, as in the movie, and not B-O-R-N. But they like to play games with names and stuff like that. But this is also, technically speaking, not the operating system. The actual operating system is invisible. It is, remember, it is like the government of society. The kernel, exactly. It's the core part of the operating system. So are there any questions about what an operating system is? The actual part of an operating system you really cannot see. What you can interact with is either a shell, like this one, it's also called a command line interface, or if you prefer the GUI part, this is the graphical user interface. But technically speaking, at least in the good old days, 20 years ago, this is not considered a part of an operating system. And even to date, this is not considered a part of Linux. Because Linux, interestingly, unlike Windows, can come with different front ends. This is called a GUI or front end. You can use GNOME, G-N-O-M-E. You can use, this is XFCE4. You can use KDE. You can use many other graphical user interfaces. Depending on how much processing power you have, how much RAM you have, and how fancy you want it to look.
Did you change your front end then? Because Debian comes comes with GNOME.
This is my own live ISO, so I customized it to use XFCE4 instead of GNOME. GNOME 2.0 used to be okay. It's not really excessively bulky. But now with GNOME 3, it's just really bulky, and they changed the way the user interface is arranged completely. So I like XFCE4 a lot better.
Yeah,
It's just
on GNOME, the window manager down here, actually, there's a separate taskbar.
GNOME 3. Yeah, that's
3.
GNOME 3. And then Ubuntu comes with its own. Is it called Unify or? Yeah. Who has used Ubuntu?
I have it on mine.
Okay.
Yeah.
What is the name of the interface? They have their own. It's not
Yeah.
GNOME
Almost
or
everybody using Ubuntu is using SFC4 though. Like they just edit the live ISO.
Yep.
Because nobody likes Unify.
Yeah. Okay. It is Unify. Okay.
Yeah.
The name is Unify. Now, if you guys want to see what it looks like, the best way, the easiest way to do it is just to go to YouTube. So go to YouTube, and then you just look for the user interfaces names. So you can look for the one I'm using right now is XFCE4, and you can look at GNOME 3. Look for GNOME 3, and here's a comparison
Unity.
between Unity and GNOME 3. And it probably works better if I make it. This is Unify, right?
I think it's Unity.
Unity, okay.
Dr. Tapp?
Yep.
So while we're watching this, I'll write the name of your YouTube account that you posted.
Oh, sure. My channel.
Your channel there.
It's just some profs. One word. I'm looking for my marker pen here. And I think this is GNOME 3. You can see that the interface looks different. I'm trying to fast forward to. Now we're back to Unify or Unity. We're back to Unity, and you can see that they arrange things differently, but yet it is the same operating system underneath. It's still Linux underneath. It's just how they dress up the graphical user interface that's different. Yep.
Windows does something kind of similar with themes.
Mm-hmm.
Themes.
Yeah, but these are not themes.
Yeah,
these are like
these are not.
completely
Yeah.
different user interfaces.
Like I said, kind of similar.
Kind of similar. If anyone wants to go for like the real minimalist, I think it's called Fluxbox. Fluxbox is a very minimalist graphical user interface. It doesn't even have menus for the most part. You just right click to start most things. So that's also an alternative. I'm just gonna show this one. Hope it will load.
It's having a Cengage one.
I mean, none of this is, discussed in the textbook. Still has a taskbar. And I turn off the audio, so the explanation is not here. But I just want to show you where you can actually go take a look at the different interfaces. We talked about this too. This is just expired, which is not as bad as some other problems that you can have with a security certificate. So are there any questions? We are getting back to which part is really the operating system, and which part is called a GUI, and which part is called a command line interface. I want to show you how I can manage different computers remotely. So I'm going to go back to my command line interface. I can use a command called SSH, which stands for Secure Shell, to remotely get control over, let's say, the power server. If you're taking a web class right now, like cisw300, 310, or whatever, you will have an account on that computer. And it will ask me for a password, but it doesn't have a username called user, so that won't work. It still requires a password, so not everybody can get into the power server and do things. Now, even when I log into the power server, I'm only logged in as a regular user. In other words, if my password is compromised, someone can come in here and delete all my files or put new files here, overwrite my files, but that person or that user cannot do anything to the system as a whole. Because the system as a whole has a different administrative user called the root user. And the root user has a different password. So now I have logged in as root, because in Linux, you can type a command, interestingly called who am I, and it'll tell you exactly who you are. So in this case, who am I says I'm root, which is the administrator. That's the name of the administrator in any type of Linux or Unix-like operating system. So that includes Linux, BSD, Mac OS X, Android, and iOS in general. Okay. So now, if I type power off and press the enter key, I am going to shut down the power server. And within 15 minutes or so, there'll be someone screaming at the door, coming in and say, "Tad, what happened to the power server?" Because they know that I'll be the only one who could do that. Okay. Are there any questions about why the command line interface is useful? Because right now, I can type commands that are executed on a remote computer, not on this particular computer. And yet, the requirement to run something like this is minimal. You can run it from a cell phone. If you have the right app to do it, you can run it from a cell phone. It's not going to cost a whole lot, in terms of using the bandwidth of your data plan. It's hardly a drop in a bucket. Because most people get 2 to 5 gigs of bandwidth, available amount of data to transfer. This is going to take up a tiny fraction of that. Yep.
It's a good segue into VoIP servers too, because I actually can do that.
Voice over IP.
Yeah, I can do that from my phone.
But there's one really big reason why we want to do some things like this. How do I automate things?
Scripts.
Now, why would anyone want to automate something? That seems like something that only system administrators would want to do. What about end users? Do end users need to automate things
Not too often.
on your computer? Well, how about defragging or defragmenting your hard drive? You might want to do that automatically. Okay. What about backing up your files? You might want that to be automatic too. Every day at a certain time, your computer would just automatically do certain things, back up the files, defrag the hard drive, clean up the hard disk, take out the trash, and so on and so forth. How do you automate something when it is done by the GUI? In other words, if I do something like this, if I have to go start up this browser here and do a right click and then do a copy and then go to somewhere else and then say paste it here, that's pretty hard to automate because there's a lot of mouse movement and you cannot automate mouse movement. Not easily. You can do it, but it's not easy. What about the commands?
You can tell it to run that program.
Exactly. So the command to back up something, okay, one really easy way to back up an entire folder in Linux is to use the tar command. Tar stands for tape archive. A lot of commands in Linux are kind of cryptic because of people don't want to use a lot of typing, right? They're all lazy. So tar ccvf, I can put it into the current folder here, okay? give this an extension, so I remember what it is. Okay, this command like this one. Okay, let me make it scroll up a little bit so everybody can see it. If you just look at this command here, the last part here, that command will back up the entire /home folder into an archive file, which is kind of like a zip file in Windows, called home.tar.gz. That's one little command. And to automate this, what I need to do to automate it is to do something like this. So I can say cron tab -e, which changes, which edits the cron tab, the cron table, which is basically a way to automate things. I have something already automated here. So I can specify at which minute. So let's say I want this to be done at 15 minutes after the hour. I can specify how often to do it. If I specify an asterisk here, that means every hour. If I say asterisk divided by 6, it means every 6 hours. And then every day in a month, and every month, and every day of a week. And then I can just type the command here. I can just say tar czvf, the same command that I was using a little bit earlier, but this time I have to specify where the file is located more completely. home.tar.gz/home. That's all I need to do. So what this is going to do is every hour at, nope, I take it back. Every 6 hours, 15 minutes after every 6 hours, it will run this command and create, and update the backup file. And that's all I need to do. So that's why the command line interface is so useful, because if you can type the command as text, it is very easy to integrate it into the cron tab, integrate it into a script, because sometimes what you want to do may involve, say, 20 steps. Okay, you don't want to retype the 20 steps all the time. You may not want to go through the GUI to complete those complex operations. So what you can do is to write a script to do it. Once you write a script to do it, you can have the cron job to execute the script instead of typing out the commands here, and it's all automated. You don't have to remember as much stuff, and it just makes the job of system administration a lot easier. So if I don't need it, I just delete it, and now it doesn't do it. Are there any questions about what the command line interface looks like and why we might want to learn how to use one? Kind of. Nobody is interested, I can see. Everybody's looking at this go like, no, I don't want to use an operating system like this.
Interesting, yeah. I said it's interesting.
It's useful for certain things. You can also see at the beginning of each class, I start a recorder using the command line. I don't really use I don't double click on something to start the recording of this class. Which also brings up an interesting point, because if you look at that script that I execute for every class to start the recording, it's not a bash script. This is written in Perl. It makes my job a whole lot easier, because this automatically takes care of a lot of stuff. It took me a while to figure out the options to specify for this command in order to capture the screen and the audio correctly. But once I figure out how to do it, I just put it into the script and I don't have to think about it again. Okay? But if I don't do it this way, and using the GUI to do it, there might be a GUI for FFmpeg, but then I have to do all the right click, or do all the menu entries, click and select and deselect stuff, use the drop-down box, and this is a whole lot easier. Any questions? If you want to learn how to use Linux, there is a class you can take. It's cisc310. That's the first class in Linux to use Linux, and then 324 is the second class. Go ahead.
So the command prompt for Windows, those are separate commands and ones for Linux?
That is correct. In Windows, when you type CMD and then press the Enter key, when you say, there's a little start text box that allows you to specify what command you want to run, and you type CMD and then press the Enter key. That's its own command line interface. So Windows has slightly different commands, like to list files in the folder, it's not ls, it's dir, dir. To remove a file is del, del for delete, but in Linux it's called rm, for remove. So the commands are slightly different, but the concept is the same. You can also create your own script, except it's not called a bash script or a shell script, it's called a batch file in DOS or Windows. So once we clear up which part is the GUI and which part is the actual core part of the operating system, we'll go ahead and continue with this topic. What does an operating system do? We talked about this already. Its function is really like a government. Okay, it's really just like a government, because on one hand we have resources. So if you look at the picture, there's a really, really quick and easy way to draw this picture. On one side we have resources. And for the most part, resources are hardware stuff. Hardware stuff like RAM, you have to go buy the memory modules and install it on the motherboard. That's RAM. The processor itself, the CPU or processor, is a resource available to everything. You have your screen, your graphics card display, sound card, network, and so on and so forth. Okay, so basically everything that is physical that you install or is already installed in the computer, those are resources available. On the other hand, we have here, we have applications, things that are actually of value to you, okay, what you actually bought the computer for. How many people bought your computer just to run Windows? Oh man, Microsoft would be so disappointed. How many people bought a Mac just to run Mac OS X? Nobody. Well, I wonder why. Well, it's because those things are of no value to an end user. Okay? What is of value to you guys? And I know what you guys think too. I know how you think because I think the same way. Okay? I want to run games on my computer. I want to play video games. Okay? I want to go online, do online shopping and stuff like that. I need a browser for that. I want to do my, write my notes. Okay? So I need a word processor of some kind to do it. In other words, these are application programs. This is what we talked about in chapter 3. Things that are actually of value to end users. Okay? Well, the question is, how do we connect from games and browsers and word processor to the hardware available to those applications? Well, one way to do this is to draw a line directly between the applications and the resources. This is one way to do it. In other words, every game will have to be written in a way that it understands all the graphics cards, all the sound cards, and so on and so forth. And it also has to know how to use the processor effectively, everything. Every browser has to do the same thing. Every word processor has to do the same thing, And when you have a hard drive, the problem here, the biggest problem is your internal storage inside the computer. In other words, if there's no operating system sitting in between, the game application can decide, oh, I want to use the hard drive this way. Okay, I'm going to store your score and your settings and stuff like that using this particular method. Your word processor can come along and say, well, it's my turn to save something. I do not like the way the game is saving your data. I'm going to use my method to save information onto the drive. But without the operating system as the intermediate step, they can overwrite each other's stuff. They can do all sorts of corruption because everybody has full control to the resources. And that's not good. Okay? And that's why we have the operating system sitting in between so that the applications will make requests to the operating system and say, hey, operating system, I need to store something to the file system. And then the operating system will then talk to the resources, particularly the hard drive here, and basically manage the use of the hard drive sectors so that it will be consistent and it's not going to do any corruption to any data that you have saved already. In other words, this really is the government. Okay, if you think about it, this is the government. These are the resources available to any country, any community, and these are citizens, companies, corporations, and businesses and whatnot, so that everything has to be quote-unquote regulated by the government. The government is the management facility for the resources. That's why we cannot have any type of air filter for our cars, because CARB says, no, you cannot have it. Nobody gets that. Hmm?
Not really.
Not really. Okay, never mind. How about trash, disposing of garbage in real life? Okay, so without the government, how would you dispose of your trash?
The street.
Huh?
The street. if there's-
Somebody else's backyard,
Yeah.
right? Just toss it over the fence.
Wait, how did that get there?
So you go to American River, American River, and just go. Oh, okay.
Slip.
There he goes, right?
We shouldn't have leaving that bubble.
Yep. So the government, has a function. It has to help to organize the disposal of, basically waste or trash, in a way that is somewhat friendly to everybody. Okay. So are we doing okay in terms of understanding the necessity and why we need an operating system? Is that okay? So if operating systems work the way it's supposed to, it should be pretty much transparent. We should not actually be able to see the operating system for the most part. But unfortunately, that's not the case. So we'll talk about some other stuff later on called maintenance items that we have to do from time to time to make sure that your operating system works correctly all the time. How do operating system manage processor resources? It's basically a monitor. In other words, when you look at this box here, it's a monitor of these resources. It understands how much RAM is used by a particular application. It can also control how much time a particular program or process here will take over the CPU. In other words, okay, let's say you have a dual core processor. Okay, dual core processor means there are two processors, basically two identical processors inside one chip. How many programs can you run at the same time? It's more than two. Okay, interestingly, it's more than two. You can basically run as many applications at the same time as you have as your memory can support. Okay, which is a lot. So how does that happen? I mean, how can we do something like that? I can show you using the command line interface here, the number of programs that are running at the same time. I have 184 programs running right now. Okay, and yet this thing has probably a quad-core processor. 3 are running and 100. Okay, 2. It just changed. 2 are running and 182 are sleeping, but nonetheless they are active. And we don't have any zombies. The word zombie actually has a specific meaning in an operating system, so there's actually a specific meaning to that.
What is it?
It has to do with a process that has died, but it won't go away.
I hate that.
It's basically a program, an undead program, that cannot be killed.
Windows.
Sorry?
Windows has that problem.
Yeah.
All operating system has that problem. It has to do with the resources that they hang on to cannot be freed when the application died, and a lot of times it has to do with which program created, which started up which other program, and when the order of the programs dying is not right, then they will start to do that. So this is an interesting view because it's basically doing the same thing as this particular view in Windows, but it's all, guess what, in text. I can do this remotely without using a lot of system resources. So PID is basically, it's called a process ID. It identifies each program that is currently in execution. User is basically who started that program. Most of these are started by an end user. When you see root, that means it's started by the system itself, by the administrator. This is priority. Everything that we can see here are priority 220. 20 is basically the lowest priority. When it goes negative, it has higher priority. So it can range from 20 to -20. When it's -20, that means it's like top priority. This is what we call a nice value. I'm not going to talk about that. This is how much virtual memory is actually using. This is how much resident memory is using. This is using the shared memory. This is how much processing resources it's taking. So you can see FFmpeg, which is the screen recorder, is taking up about 61% of a single processor, a single core in this system. It's taking a lot of resources. And that's because it's transcoding at the same time. For those of you who know what transcoding is, you know transcoding can take a lot of processing resources. And that's why it's taking up quite a bit of resources here. But it's not taking up a lot of RAM, because in terms of memory, it's only taking up 2.1%. And this is the amount of time it has taken up to this point. It has taken 21 minutes, 48 seconds, 48.24 seconds up to this point of processing resources. So that's how we can kind of visualize and see how much resources is used up by which particular program that is in execution. You can also see this is called the load average. The higher the number, the more busy the system is. But it doesn't really correspond to, well, maybe I need a faster processor. Because what this means in terms of load average is basically saying how, on the average, how many programs in execution is waiting for something. Now that something can be the processor. It's possible that all the programs are using up all the processing resources, but it can also be the hard drive, a slow device, the network. Okay? So in other words, if a program needs to send out a lot of information through the network card, but your NIC is only capable of sending out information at a certain speed, you will still have a high load average because it is still waiting for that particular resource. It shows how much RAM is available. We have basically 4 gigs of RAM available. We are currently using 2 gigs out of that, but out of the 2 gigs that I'm using, 1.5 gigs are cache. So the actual amount of memory used by the system is not really that much. It's less than half a gig in this case. Are there any questions about this screen? Because I'm just using it to explain the concepts. When you read the textbook, it has about the same thing, except it's displayed in a much more graphical user interface kind of method. The next part is how does an operating system handle so many processes? And this is interesting. What do you think? We have a certain limited number of processors. Even with a hexa-core processor, you only have 6 cores, and with hyperthreading, you have 12 quote-unquote concurrent hardware that can run things at the same time. But obviously, we can have a lot more programs in execution than just 12. So what it does is called time sharing. And time sharing is interesting because the operating system sets up a timer, okay? Just like a kitchen timer, except it's a lot faster. And it will basically say to each program in execution and say, okay, I'll let you run for 10 milliseconds. And set a timer for 10 milliseconds. When the timer goes off and the process, the program in execution is still, I'm not done yet, I'm still doing stuff. Okay, I'm sorry, but I have to remove the processor from you now and give it to the next process. So the process that was running, that was hogging the processor, will be put to sleep. Okay, it will be put to sleep, basically suspended, until the round robin method comes back around and say, okay, it's your turn again to get more processing resources. And that's how you can have a huge number of programs in execution when there are only like 4 or 8 or whatever number of cores. Are there any questions about this part? No questions? So the operating system is really quite a complex piece of software because it has to do all these managements, monitoring, and other stuff. The terms defined here is not exactly correct because these are Microsoft terms. Multitasking provides process and memory management services that allow 2 or more task jobs or programs to run simultaneously. And then it separates multi-threading within the okay, I take it back. This is the correct definition of the terms because Microsoft defined these terms differently. In our case, you don't have to worry about the separation or the differences between multitasking, multiprocessing, and multi-threading. The way it's defined here is really kind of this part here it is supposed to be multiprocessing. This is multi-threading, and that's correct. There's no the way multiprocessing is defined in the textbook is according to the Microsoft definition, which is not the computer science definition. It's not the first time.
won't be the last either.
How does the operating system manage memory? Basically, it does memory allocation. In other words, when a program, such as here, when your game application says, I need more RAM to store a map, okay? Well, it doesn't just go to the memory of your system and say, okay, I'm going to use this portion of memory because somebody else or some other application can be using that portion of memory already. So what it needs to do is your game app has to request the memory from the operating system and say, okay, operating system, it can be Linux, can be Windows, can be Mac OS 10, it doesn't matter because every operating system has a similar interface. So the operating system will say, okay, I know you want to have, 512 more megabytes of memory. Then the operating system will check how much memory is currently in use, which part is available, and if there's not enough memory available, it can use what we call virtual memory. But anyway, the operating system will try its best to allocate the 512 megabytes of memory. If it is available, it will give that memory back to the game application and say, hey, this is a token. You can use this token to access that chunk of memory. So that's how memory allocation is done. Sometimes an application requests memory but never releases it. This is a condition called memory leak. Firefox used to have extremely bad memory leak. When you run Firefox for a few days, it will take up a lot of memory in your system. I don't think that's the case anymore. Any questions? Comments? Okay. These programs can crash, and the operating system may display error messages such as GPF, general protection fault, or program not responding. There are many other reasons why you can get a general protection fault. Basically, every time your program does something it's not supposed to, you get a GPF, general protection fault. The general protection fault is a very technical term. The processor actually has specific hardware to generate the fault, but that's kind of besides the, it's not within the scope of this class. How does the operating system keep track of storage resources? Well, it's called, a file system. Okay, and NTFS and FAT32 are not the only file systems in the world. They are the only two natively supported by Windows, but they're not the only two file systems.
For extension 2 as well.
Extension 2 is supported now natively?
Yeah. Windows.
Okay.
You can format a hard drive in extension 2 and use it on Windows.
Oh, okay. Without having to install additional software or modules.
It's plug and play. You can't install the OS on extension 2.
Right.
But you can put files on an extension 2.
Interesting. Took them long enough.
Yeah. But like extension 3 and extension 4 are not.
Oh.
Yeah.
Then
The better two are not. So.
okay. Why does the operating system get involved with peripheral devices? Because every application wants to use them. And somebody has to manage the use of those devices. What devices are we talking about? Think about the keyboard, okay? When I type something on the keyboard, which application is going to get the text, the keystrokes? All of them, none of them, or one of them? One of them, right? Whichever application is quote unquote active at a time or has the focus, it's just called the focus, is going to get the keyboard and the mouse events. Okay? And that's why the operating system is so important, because without the operating system and you have all these programs running at the same time, they're all asking, is there any keystroke on the keyboard? When someone types something, it's not intended to all the programs. It's only intended to one program. And that's why the operating system is important. What about your sound card? All of these programs can run at the same time, and they might all want to generate some sound event at the same time. I forgot about it, so
Okay.
you don't need it. But these things can run at the same time. How many people have run a game and a browser at the same time? Okay. Can both of these, use the video and also the sound at the same time? Obviously, games, use, video and sound, but you can also be watching on YouTube, a clip at the same time. So how does your sound card deal with it? Do you need one sound card per application? No.
Different channel.
Well, different channels, but they're actually getting mixed by software. It's actually the driver that is doing the mixing. It's not a hardware mix. Okay. So that means, that's why the operating system is involved in the middle, because both of these applications are saying, oh, I want to use the sound card. The operating system will combine the output from both programs into one single output to the sound card. Okay? So all devices are actually managed by the operating system, so that everything, hardware is on this side, everything that is of value to an end user is on this side. The operating system is sitting in between everything. This part is kind of interesting. Are different operating systems needed for different computing tasks? And it talks about single user operating system, multi-user operating system, and server operating system. In Windows, there's a very big distinction, because what is otherwise known as a single user operating system in Windows terms? Home, okay? Even though you can set up multiple users, how many people typically will use it at one particular time? One user, okay? And then we have server operating systems. In Windows, what makes a server operating system a server operating system? It's serving other computers. It's not end users anymore. We are talking about it's serving other programs. Remember the discussion of a database? So when you have a database, okay, there's a database application, can be any type of database application. It's running on one single box. But you can now have multiple computers, a laptop computer, a tablet here, another desktop computer, and they can all be interacting with the database server at the same time. So that turns this particular computer into a server computer. It's no longer just a end user computer. It is now used to serve requests from multiple other computers, and typically through the network. But this distinction, when we look at this part here, this distinction of single user, multi-user, and server operating system is completely artificial. Okay? In all operating systems, including Windows, at the core of the operating system, there is no distinction among these three. Unless you're talking about DOS, which is a really ancient operating system, which nobody really cares, all distinctions are really artificial. Why do you think there's an artificial distinction amongst all these different types of how you use an operating system?
Because it's all based on the shell and not the kernel?
Not exactly. It's all because companies need to make money. How much do you pay for a home license, Windows 7 home license? $100 or so, something like that, okay? How much do you pay for Windows Server 8, 2008?
I think it's lasted just like.
Well, it's a very interesting scheme, because it depends on how many connections can you make at any particular time. In other words, if you make your database server here to only have up to 5 computers to connect to it at any particular time, it's one price. If you make it 50, it's another price. If you make it unlimited, it's yet another price. But inside the operating system is really the same core. Okay, it's the same kernel. So the difference between server, professional, home, and all the other quote-unquote additions of an operating system is completely artificial. It's marketing. It's like Buick versus Chevrolet versus Oldsmobile, which is not anymore. Okay? What is the distinction? Sometimes they have exactly the same car, don't they? Okay, different trim, maybe, different interior design, maybe, but it's really the same car. Same engine, same transmission, same everything at the core, same chassis. It's the same thing with operating systems. In other words, if I go back to the previous slide here, we are talking about the DX trim, the LX trim, and this is the EX special edition trim. But inside, it's the same. Maybe little tweaks of the suspension and exhaust and climate control and stuff like that, but the most important part of the application, or the program in this case, is really the same. Okay. Are there any questions about that part? Is anyone planning to run your home computer or turn one of your home computers into a server, or have already done so? Okay, I know some people have done it already. Why would you want to do that? Why would you want to turn your home computer into a server? It may not be used to serve everybody. It can serve only you, so that you can store all your programs, all your documents there, and then you can access your documents through whatever device you're using. Go ahead.
Backing up is a good way to use. One of the good ways to use a server, especially if you have one with a large amount of space, is for backing up home computers and for remote access and restore.
You can use it for backup purposes. You can also use it to share files. Okay, if you live in a household, where somebody takes a lot of pictures, but everybody wants to mess around with the pictures, having a file server is one easy way so that you can share the files, to every computer without having to use USB thumb drives and whatnot to transport the files.
The interesting thing about that, though, it goes back to how all operating systems are the same, they just have a different name. It's like, in Windows specifically, you can use home group to share files.
But they put a limit of how many computers can share at the same time.
Yeah, it's 5.
Is it? Yeah, it's really interesting because I taught one class, it's a networking class before, and I put one file on my desktop computer inside the classroom, and I told all the students how to find that file, and say, okay, you just have to go to my computer and download that file. I expose it, through your Windows sharing, and then very quickly, within minutes, I have complaints and go, but I can't download that file. It's not letting me copy the file. It's because of the 5 connection at the same time limitation, which is completely, guess what, artificial. The kernel really doesn't care. It's an artificial limit so that I can no longer use that particular edition of Windows. I have to upgrade it to Windows, a server operating system in order to serve more than 5 computers at the same time.
Just download Linux. Just download Linux.
Well, the campus has a site license, so we can actually install any operating system on any computer, but nonetheless it doesn't change the fact that all the different editions of Windows are mostly artificial. It's not there's really very little difference between the versions or the editions. Do I ever interact directly with the operating system? The only time you do that would be when you manage files. That's really the only time that is really necessary, and also when you want to customize the user interface. Configure equipment, I think it should not require user interaction. Okay, but the way it is set up right now, it does. Okay, you have to install the driver. Most drivers, if you look at this one here, configure equipment, most hardware can auto-config. In other words, when you plug in a USB device, Windows will try to look for the driver for that thing. And if it does, it will install it automatically, and you can use the device without having to pop in a CD or install the driver software. And that's basically why we have the control panel. The control panel is the central access point so that you can do all the configuration. This part we talked about already, the user interface. We have the text user interface here, and then we have the graphical user interface. And I just, go ahead.
Did you do roll?
I'm not going to do roll today. I forgot to bring the roll.
Okay.
It's okay. And I want to make sure that I'm still recording. Yep. So I just explained, early on, so I'm gonna skip this topic a little bit because I explained that already. Command line user interface can be accessed from most operating systems, including Windows and Mac OS, and also Linux, because almost all Unix type operating systems are very centric around, they center around the command line interface more so than anything else. The Mac OS X, interestingly, is actually a true Unix operating system. Unlike Linux. Linux is kind of like a Unix look-alike. It's never really truly Unix. But Mac OS X is actually Unix. It's a BSD distribution, so it's considered genuine Unix and not look-alike. And most computers today have a graphical user interface, abbreviated as GUI, because it just lets you use the computer more conveniently. Next slide talks about the basic elements of a GUI. You have a desktop. Okay, if I were to show you a blank desktop, this is a desktop. And on the desktop, you can have icons, kind of the stuff that you commonly want to use or have access to. And then you have either a taskbar or a panel. It serves the same purpose. A way for you to start, your programs and applications. And then once you start a particular application, like Stellarium, then the program starts. Okay, complaints about OpenGL. Gotta fix that. But I can start up, IceVisel. It's a browser. And that's pretty much, the user interface. I don't use IceVisel, so I can just skip that here. Are there any questions about how to use Windows or identifying the major parts of the Windows GUI, graphical user interface? Any questions? Really? Well, if you don't have questions now, you will have questions when you upgrade to Windows 8 because it doesn't look the same.
Don't do it.
Won't do it. I'm pretty sure by the time they have a retail version of Windows 8, there will be one quick, easy way to switch back to the Windows 7 look.
Well, if you don't have a touchscreen or tablet, then you get the Windows 7 look automatically.
Oh, it does it?
You don't get light tiles.
Then why get it?
Exactly.
Then why get it?
It's only it's a $40 upgrade if you have Windows 7. But here's the deal. You cannot upgrade to 7 or to 8 if you have Home Premium, like directly.
Because Home Premium
have
is
to
what
reinstall
usually comes with most computers.
Right, you have to reinstall Windows 8 completely if you have Home Premium.
So you
And-
need a different license. You cannot use an upgrade license.
Right,
You
but if
need a
have
full license.
Pro or
for that.
Ultimate, you can.
Great.
Yeah, still $40, but like you have to do a complete
It's
reinstall.
not going there.
Yeah.
Okay, so inside the graphical user interface, we have all sorts of stuff, for interaction purposes. We are looking at a few already. This is a scroll bar. This is a button. We have the title bar of an application. We have the menus, and then we have menu items, and some will trigger dialog boxes. Are there any questions? No, most of you know how to use Windows already.
Yeah.
Okay, submenu. Some menus have smaller items under that. It's called a submenu. This part here, the ribbon, the ribbon concept is unique to Microsoft Office or Microsoft products. Any questions about this part? No. Okay. Moving on. The boot process. This is interesting stuff. Most people think of this process go like, well, I don't even care about this process. This is actually very important because you have to understand how your computer starts up if you want to use any alternatives to the system to whatever is already installed in the system. When you power up, the computer will basically just distribute power to all the components, but you have to be careful because sometimes certain components are powered up even without your computer being quote-unquote powered on. In other words, try to plug in a USB charger to the USB port of a computer, even when it's off, some computer will still have enough juice on the USB ports to charge your cell phones and other stuff. Okay, so that means the computer is not exactly off. Even when the light is off, it's not completely off. It starts the bootstrap process. It's getting its memory, it's getting its program from ROM, read-only memory, because at that point, it has not accessed the devices yet. So the hard drive it doesn't even know whether there's a hard drive yet. The self-test part, is diagnostic, but the most important part of the power on self-test is double checking everything is okay, and also figuring out how much memory you have on the motherboard. Okay? In other words, every time you start up the computer, it will do the self-check and see how much memory is actually installed in the system. And then it will go ahead and identify some of the peripheral devices. The most important peripheral devices before it actually bootstraps into an operating system will be the screen, the keyboard, and the mass store device. In other words, your hard drive or USB thumb drives. Because those are the components that it needs in order to do some basic interaction to configure the BIOS settings. BIOS stands for Basic Input-Output System. Once it finds a mass store device that is bootable, it will load the operating system from the mass store device, such as your hard drive, your USB thumb drive, SD card, and so on and so forth. And once your operating system starts to start up, then it will do the rest of the bootstrap process. Here's the question. If you want to disable a system from bootstrapping into Windows, how much work do you need to do? The answer is not a whole lot. You just have to destroy the master boot record or corrupt it. Then most computers cannot start up anymore. So that's a common problem, the master boot record getting corrupted. And to relate this, all the way back to security concerns that we talked about earlier. Sorry?
Isn't that what boot sector viruses do?
Yep, they can install themselves all the way to the boot sector. So that means by the time your operating system gets control, it cannot be trusted anymore. Pretty nasty. Why doesn't the computer simply leave the operating system in memory? Some computers do, actually. But for the most part, you cannot do it because when the computer is turned off, you will lose the content in RAM, or random access memory. In other words, everything that I'm doing here will be lost when I turn off the computer. But that concept is getting challenged increasingly because there are devices now that does not require a lot of power to maintain its memory. How many people never turn off the computer and just put it to sleep when you need to walk away? Or have the computer to automatically do it? So you're basically doing it already. In other words, you are quote-unquote turning off the computer because in sleep state, your computer only consumes a tiny fraction of the power that it needs otherwise to run the computer. But yet, when you click something, when you click the mouse, your computer wakes up and it's exactly at where you left it when you ask it to go to sleep.
Most of the time.
Most of the time, yes.
Especially
Especially if you unplug or plug in devices, in between, then that can cause problems. Yep.
When you suspend a computer, basically, doesn't it just push all the processes that are active into the RAM? And then
No, it doesn't do anything. Actually, when you ask your computer to sleep, the only thing it does is to properly shut down the peripherals, because some peripherals, you need to store the state into memory first. But when a computer is sleeping, its memory is still active. It is still maintaining the content memory. When you're hibernating, then you're storing everything onto the hard drive because the computer is actually off technically in that case. So there's a big difference between sleeping or suspending and hibernating, because hibernation takes a lot more time to set up. But when the computer is hibernating, it's really not consuming any power. Zero power, basically. But when it's sleeping, it's still draining power, just a lot less than when it's running.
just enough to run like processor RAM. and
Right.
hard drive.
Like with a laptop computer, if you let a laptop computer sleep in Windows, it will eventually run out of battery power. Maybe it will take 2 or 3 days, but it will run out eventually. But if you put it in hibernation, then it's only the self-discharge of the battery that is draining, energy. So that can last at least, a week or so. So it does make a big difference whether you're suspending or hibernating. Moving on. This picture is kind of okay. It just shows the order of, how the program goes. Goes from ROM. It's not even that. It's basically what is supplying the instruction to the processor. So first, it is the ROM supplying instruction directly to the processor, and then it will copy certain things to the RAM. So this order is actually incorrect because it will load certain things to the RAM, and then it will run from RAM, and then that program will load information from the hard drive into RAM again, and for the most part, your operating system should run its program either from ROM directly or from RAM. It can never run anything from the hard drive directly. How do I know when the operating system is loaded? Well, that's why you have the fancy Windows splash screen with all the dots coming together to make the Windows logo. It displays a system prompt or logs you in automatically. That's basically the bottom line. Today's operating system, I really kind of like this picture because it's ignoring the fact that Linux is in Android. And I think WebOS is also Linux-based. iOS is Linux-based, is Unix-based, and it's missing entirely from this picture. And Mac OS 10, okay, if you look at this picture here, Mac OS 10 and iOS actually has the same core operating system, which is BSD, Berkeley Standard Distribution. So I would reorganize this picture a little bit and not make a differentiation between handheld versus the other operating systems. Yep.
OS X and iOS almost look identical from the front and side too. They're getting close.
They are?
Yeah.
But at the core, they are exactly the same. They are BSD, which is Unix. And that's why a lot of Linux tricks that people learn also applies to Mac OS 10. A lot of the commands like SSH, if you have a Mac running OS 10, you can run SSH the same way too, because they are really the same type of operating system. Okay, so here's a little spiel of Microsoft Windows, saying it's the best selling operating system, and there are reasons why it's the best operating system. Why do you think it's the best selling operating system? It's because Microsoft is extremely good at marketing and strong arming. Those are the two things. So there's a timeline. Let me skip to the timeline first. Okay, here's a timeline. I know you guys cannot read it, but I'll go ahead and explain the history of Microsoft Windows. Before Windows, what do we have from Microsoft as an operating system?
DOS.
We have DOS. Okay, DOS stands for. I only know DOS from DOS Coyote. Is it DOS Coyote? Yeah. Okay. Anyway, what is DOS? It's Disk Operating System. Okay, that's its name, Disk Operating System. How did we get the DOS? Why do we have DOS in the first place?
Why we used to have DOS?
Yeah. What is the history of DOS itself?
Because back then computers run on floppy drives.
Okay.
It doesn't actually have any of its own physical memory. So
The GUI wasn't even invented yet.
Okay, so all right, which company was responsible? Which companies? Two companies were responsible for DOS. IBM is one, and Microsoft is the other one. So what did IBM do? IBM came up with the IBM PC, right? The hardware, the PC hardware, personal computer, which was not really personal to begin with. So it came up with the hardware. IBM was really good with that sort of thing, coming up with the hardware, selecting the processor, designing the circuit board, everything was done. But what do you get? What do you have when you just have the hardware of a computer, but not really the software to make it work? It's a heater, right? Okay, it's a brake, it's a heater, it's a door stop. Okay. So IBM contacted Microsoft and say, hey, Microsoft, Bill Gates at the time, Bill Gates and all the big guys were still there, and the IBM contracted Microsoft to make an operating system for the IBM PC personal computer, so that IBM can start to sell the computer and actually make use of it. Okay. So what do you think Bill Gates did? Do you think Bill Gates, took the money and then turn around and just stay in his computer lab or garage, spend months and months and months to write the operating system? No, he looked around and go like, let's see if anybody else has an operating system already. Okay, so the first thing he thought of was CPM. CPM stands for Control Program / Master. This is all historical, but I think the history is very interesting in this case. So CPM is an operating system, not cost per mile. CPM, Control Program Microcomputers. Okay, there we go. CP/M. Okay. So somebody wrote an operating system already for the processor that IBM chose to put into the original IBM PC. This was intentional originally for the 8080, 8085 processor, but the 8088 processor that IBM chose to use was backward compatible, so CPM would actually run with that processor. So Bill Gates approached the person who wrote CPM and asked that guy and say, well, would you like to license that software to me so that I can return license it to IBM? But the person was not home at the time. He went, golfing. The wife answered the door, looked at Bill Gates with a suitcase of money and go, no, we're not interested, slammed the door. Not literally that, but turned him away, okay? So Bill Gates, thought, okay, this didn't work out. So he found somebody else who wrote a CPM clone, so that operated just like CPM, has the same user interface and everything, it will run on the same hardware. Approach that person with $50,000. I think you can look up the numbers. I mean, I think it was $50,000, and ask that person, would you license that software to me so that I can choose how to use that software any way I want? I want the source code along with that too. $50,000, and that was back in the early '80s. So I guess $50,000 was a chunk of money, but it's not really that big of a chunk of money. Okay. And that person just jumped on the first chance and say, "Yep, okay, it's yours now." Okay, took the money, and so now Microsoft had the CPM clone operating system, which then it re-licensed and relabeled it as PC DOS. Okay, so that's only half of the story. That's only half of the story. So when Microsoft went back to IBM and say, "Yep, you have your operating system now, but don't ask me how I got it," right? So here's PC DOS, and then Bill Gates was smart enough to ask IBM and say, "Can I add something to the licensing, with this product, so that I can resell this operating system under a different name any way I want to?" So Bill Gates, added that little part to the agreement. IBM didn't think much of it because IBM was thinking, hey, it doesn't really matter because it has to run on my hardware, right? So people will be buying my PC. If you want to license your own software, hey, it's no loss to me. No big deal. It's okay. Yep.
$50,000 adjusted for inflation is $135,000 today.
$135,000. But that's like giving away the entire software, all the rights and whatnot. Yeah. Okay. And anyway, IBM didn't think much of the additional clause to the agreement and just said, okay, sure, no problem, sign it. Okay. And then what happened? Which company came along really kind of soon after IBM came up with PCs? Apple. No, not Apple predated that. It was a company called Compaq. COMPAQ. Okay. which is a name that most of you don't even know because it was absorbed by
HP.
HP. Exactly. Very good.
I remember we used to have an old compact with one of those 40-pound monitors.
Yes.
Like a 40 gigabyte hard drive. For
Oh yeah. Now, why do you think Compaq has a branding of compact?
It's because it was small to the general computer at the time.
It was the first company to make, or one of the first companies to make a what they call a luggable computer. Not a portable computer. It's called a luggable computer. A luggable computer is basically bigger, in this case of a mid-tower computer, and much heavier too. This is probably around 20 pounds. And the luggable computers with a CRT monitor and all the full size, floppy drive and whatnot inside, those things are 40, 50 pounds each. Yeah, it's like a small generator in terms of weight. And that's what Compaq started to sell. And guess which operating system it was using?
DOS.
It was using MS-DOS, okay? Which is the same as PC-DOS, except it was licensed directly by Microsoft and not IBM, okay? And the rest is just history, right? Compaq was only the first one of the first companies to make PC clones, and then after that, the rest you already know. How many different brands of PCs do we have now? Even after many companies, folded. We have a ton. Yep.
PC like a box PC or PC like a laptop?
Doesn't matter. Just brand names. Brand name of PCs. So as an exercise, this is not a quiz, not a homework, but just as an exercise, think what would have happened instead if IBM chose not to let Microsoft license the software under its own name. Just kind of imagine, what would have happened in that case.
IBM would be a multi-billion-dollar corporation.
Not unless they know how to write the program.
So it's just a licensing agreement. That was just a licensing agreement between Microsoft and IBM. But if IBM had chosen not to let Microsoft rebrand PC-DOS and sell it on its own,
Then Apple would have actually been #1.
exactly.
Because Steve Wozniak was the one who wrote it on himself with his own idea with Steve Jobs in the garage.
Yep.
And since IBM doesn't know how to program it because Bill Gates is the one who bought it for them, they wouldn't know how to reprogram it.
Bill Gates didn't know either.
Yeah, so
he didn't write
he
it.
just cloned it himself. He
Yep.
cloned the clone.
Yep.
To clone it now.
Yep. He bought the clone of a program, and then licensed it or sold it to IBM.
So how did you get all the way to Windows 8?
Windows 8? Well, we'll talk about it on Thursday. It's a long history, right?
Starts with